Okay, so now let's look at the linear stuff. We did the linear stuff next, I believe, on the test. So I'm going to go ahead and work on the linear stuff. All right, so number 8 says points A is at 1, 1. B is at -3, +1. So here's A, here's B. C is at 1, -2. So the question is, what do the slopes of AB and AC indicate about the two sides of the triangle? Okay, look at AB. AB is what kind of line? That is a horizontal line, right? Okay, that's a horizontal line. What is AC? AC is a vertical line. So you've got AB and AC. If one's horizontal and one's vertical, they're perpendicular. First of all, you could have eliminated C. They're not parallel. They're not parallel, okay? Parallel means they never intersect. They're congruent. Well, does slope have anything to do with congruence? No. Slope doesn't tell us anything about length. And they're not congruent anyway, because 1, 2, 3, 1, 2, 3, 4. And they both have negative slopes. Nope, that's not possible. This one, remember, horizontal has a slope of 0. Vertical has no slope. Remember, we talked about that. So the only option is that they are perpendicular. Okay, so let's go down to the next one. Let's look at number 12. Now, number 12, we did some of these on Plickers. Which equation best represents a line parallel to a line passing through these points? Okay, well, if we're looking for parallel, we know right off the bat we're looking for same slope. Okay, we're looking for the same slope. So I want to take these two guys. These two guys are on my current line that I have. And I want to know my current line is parallel to which of these guys. So let's find the slope first. Remember, slope is y2 minus y1, the change in y over the change in x. Okay, so I'm going to rewrite my formula, and I'm going to plug in, and let's use some color here because we always love color. My two y values are -8 and 2, and my x values are 1 and -1. Okay, so when I do this calculation, a lot of you had trouble. You either switched x and y and you put the x's on top. Remember, y's are on the top. Or you messed up negatives. What's -8 take away 2 more? -10. What's 1 minus -1? Minus a negative changes to plus a positive. That becomes 2. So the slope is -5. So the slope that I have is -5, and I'm looking for a parallel. I'm looking for the same slope. So I come over here. Which one of these has a slope of -5? A does. Because my slope is right there. Okay, so that is how we do that one. Okay, so that gets you through the first two. And let's move over here. All right, so what we're going to be doing, with these is I'm going to be looking at this and determining, whoops, this one actually looks like my printed copy is not behaving. So what it should say, because this has just been that kind of night, right guys? Okay, determine an equation. Oh, I see what it did. It threw it on the previous page. So what you're doing is you're determining an equation of a line that passes through P for -1 and is perpendicular, and that's perpendicular to M. Now this is line M. I told you that was line M. So I want to know the equation of a line that passes through that point and is perpendicular to this one. Well, I've got a point, so I need to find a slope. Okay, so I'm going to find the slope of this line. We can do slope the old-fashioned way, or you can do it the slope formula way. The old-fashioned way is rise over run, right? So I'm going to go 1, 2, 3, 4. So I went up 4. And then over 1, 2, 3 to the right. 4/3 is my slope. If you want to do slope formula, you do y2 minus y1 over x2 minus x1. And you get, this point is located, this is where a lot of you ran into trouble. Guys, this is at -1, -1, not -1, 1, ding dongs. And this one is at 2, 3, okay? So my two y's are 3 and -1, so I would have had 3 Sorry. 2, 3. Okay. So my two y's are 3 and negative 1, so I have 3 minus negative 1 on the top. And then on the bottom I have 2 minus negative 1. The minus and negatives change to pluses, and boom, 4/3. Okay, but here's the problem. 4/3 is the slope of this line. I want the perpendicular. So if 4/3 is the slope, what are perpendicular lines? Perpendicular lines are opposite reciprocals, if you guys remember that, okay? Perpendicular lines are opposite reciprocals. Sorry, I'm taking care of something right quick. Sorry, I'm taking care of something. Okay, so we want opposite reciprocals. So the opposite reciprocal would be -3/4. Okay, -3/4. So I've got opposite and I've got flip. So I'm going to use this slope and this point to find my equation. Again, I'm looking for a line that's perpendicular to that one. That one has a slope of 4/3, so I'm looking for a line that has a slope of -3/4. Some of you guys forgot to flip it. Okay, so now I'm going to use the point slope formula first. This is point slope. Okay, so I'm going to plug in, I'm going to rewrite, whoops, I shouldn't have written that. I'm going to rewrite the formula, but without my plugins. Well, what slope am I going to use? -3/4. That goes in for slope. What am I going to use for my coordinates? Well, I know it goes through this point, so I know that -1 should be here and 4 should be here. And from there, it's just algebra, which a lot of you have a phobia of. Minus a negative changes to plus a positive, so I got y plus 2 equals, now we're going to distribute, -3/4 x, -3/4 times -4/1. What happens with the negatives? They cancel. Those cancel, so I get plus 3. Okay? Then I've got one more step. And that final step is to get the y all by itself. So I'm going to subtract 2 from both sides. So y equals -3/4 x plus 1. Now, if you look at this, okay, if you look at this carefully, you'll see that if I do this and I do down 3, 1, 2, 3/4, this does look like it kind of makes a right angle, right? I just did the slope and the y-intercept. So you can tell that you're actually probably on the right track, okay? So that's how you do those. Now on the next 3, I pulled these right off of the review. It asks you if they're parallel, perpendicular, or neither. Well, when you look at them, what does parallel mean? Same slope, right? Perpendicular, opposite reciprocal slopes, right? And neither means it's neither. Remember when you have y equals mx plus b, that's your slope. Okay, that's your slope. So let's look at these now and kind of determine what we got. All right, first of all, in the first one, what are my slopes? I have +2/3 and -3/2. Are those the same? No. Are they opposite? Yes. And reciprocal? Yes. So these are perpendicular. Okay, so let's look at B. B, what are my two slopes? Uh-oh, watch out, I have a runaway marker. 2 and 2, right? +2 and +2. Are they the same? Yes, they're parallel. Okay. The next one I have is the last one, which I've got the slope of the first line is +3/4. The slope of the second one is -1/5. Are those the same? Nope. Are they opposite and reciprocal? Nope. So these were neither. Okay. So that's how you do those. Okay. All right. So let's do the last two. The last two, this one we're going to find the slope. And again, I gave you the slope formula. It's the change in y over the change in x. So I'm going to plug in. And my two y values are 12 and 4. So I'm going to plug those in for y. And my two x values are 3 and -9. So I'm going to plug those in for x. And a lot of you got to this point, but then you didn't reduce, so you lost 1 point, one measly point. Or you ended up messing up your positives and negatives again. 12 minus 4 is 8. 3 minus a negative becomes plus a positive, which is 12. And then, so you get 8 over 12. But I want you to reduce. These needs to be in smallest form. So it was 2/3. If you didn't reduce it to 2/3, you lost 1 point out of 12. So you got most credit. All right, last one on the linear side. So on the linear side here, we're looking at put the following equation in slope-intercept form. Well, what's slope-intercept form? Well, slope-intercept form is y equals mx plus b. So I want to get y all by itself. So I'm going to come over here, and I'm going to start moving things around so that I get y alone. So the first thing I'm going to do is I'm going to add that 9x to both sides of the equation because I want to get rid of the x term and move it to the other side. And it becomes positive when I move it over. Some of you had problems with positives and negatives on this, okay? But I'm not done yet. I want 1y. That y is the same as 1y. How do I get 1? Well, I divide by whatever is there. So I'm going to divide by -4, and I'm going to divide everything in the equation by -4. I have to keep it equitable. So -4 divided by -4 is 1y. 9x over -4 is just -9/4 x. And -12 divided by -4 is +3. So there is your slope-intercept form. So that concludes the linear portion, and I'll film the angles in just a bit.